Now it turns out that writing all the appies and lammies to do this would be very painful. Let me show you a different way to do that. Let me show you in terms of let. So here is our just lambda form, where we have our just lambda interpreter, where we have lammy and we have a parser that matches let. And here we were directly producing a lammy and appy. That's the thing that's going to be very painful to produce for the letrec encoding. But let me write it a different way. What I'm really doing here is pulling out the name, the right-hand side, and the body as S expressions. So here is the name as an S expression. And here is the right-hand side as an S expression. Right, second of BS is this symbol here, and then the body, this part here, that's the third of S. And once we have those as S expressions, we wanted to put them together back as lambda, name, body, applied to the right-hand side, like that. And we could parse that, but if we do that as written, then the parser will see literally name, and it'll see literally the identifier body. That's not what we want. We want the S expression that we pulled out here. And with backquote, we can use a comma to escape and drop those actual S expressions in there in place. So if we do that instead of this epi, actually let me just delete it. Right? This is the same implementation of let in terms of lambda. If we run it, then all our test cases will work. But it's a little easier to see what's going on. It's a little easier to see that we're matching this pattern. We're pulling out name, right-hand side, and body, putting it back together in this form, and then calling parse on that whole thing. So the same sort of strategy will be a good idea to implement the conversion of letrec into this form here.